Okay, you know what happened when where is everybody? It has been 15 minutes. When I run this code, it's going to memory leak every time I make this new because I am not deleting it. But if I delete this pointer PT, and if I run this, okay, compile and run. What happened? Where is? Oh, okay, because compile and run. Okay, it is just calling destructor over and over and over again. Let me cut this out. Well, maybe I can do this. Okay, maybe I can do it this way. So it is calling no parameter constructor and destructor, no parameter constructor and destructor all over again. And when I look at my task manager, where is my task manager? This is my task manager, yeah. So remember the size of it? Okay. Its size is somewhere fixed. It's not increasing. And let's see my main memory. Yeah, it is around somewhere like 67%, 68%. It's not increasing because I am not using any more memory than that simple process. Okay, it's going to continue until infinity. Okay, nobody will stop this if I don't stop it because it's not doing anything that leaks from the memory. Okay, it's not doing anything that leaks from the memory. Do this kind of experiments too. Okay, so you understand what is going on. By the way, let's do this experiment. PT, what was the character? W. So this is what kind of problem is this? What did I do now? So you are coming 20 minutes. You are taking 20-minute break. Is that what you are doing? It has been 20 minutes since I left you. Why are you guys late? I am talking to you. Why are you late? You don't know, you don't care? The break is 10 minutes, it is not 20 minutes. Okay, so what did I do wrong? Line 30. Assigned to a dangling pointer. Am I going to get any crashes? I don't know. Am I doing something bad? Definitely, yeah. Let's do this. Let's compile and run. Okay. Well, immediately after I started, no parameter constructor, destructor, yeah, definitely it crashed. Okay. But it didn't have to crash. After the delete, it didn't have to crash. But if I do this assignment, PT what? You have a question? If I do this assignment now, or can I do, yeah, okay. I am not sure if I am using the C++11 compiler, that's why I didn't use null PTR, but that would have been, this will, if this compiles, yeah, this will definitely crash because I know that after delete, okay, after delete, it is, I assign this null, then this will crash, okay. But if I don't do this, from time to time, it may not crash. Sometimes it will crash, sometimes it may not, depending on your compiler, depending on your environment, and etc. It may not crash. Yeah.
In line 28, copy constructor works due to a pointer or new a?
What the copy constructor doesn't work. What did I say about?
Line in 28.
It is not copy constructor. It is just a no parameter constructor.
No parameter constructor works due to A pointer or new A?
Which one do you think?
I guess new A.
This is not an object of A. This is an A pointer. PT, the type of PT is not, okay, type of PT is not A. It is A pointer. So to make a new PT, okay, no copy constructors or constructors will be called. Okay, PT is simple pointer. Okay, so line 30 will cause the calling of the constructor, no parameter constructor. Okay, good. So we talked about the assignment. So you do this experiment yourself at home. Try different stuff. Try to make another class B, okay, my favorite class, and put B in this one, B and B, okay, and place all of these printouts inside this class B and see what's happening with this B, okay. Good. So I like to do this. It is not 11, right? It is chapter 10, and we did not finish up with this PFRAD. Let me open it. We already did this, right? Let's look at the header file. Remember what we did about our client code is give me a size PFRAD with this size. I initialize it, so let's say I have 10 integers in it. Okay, 10 doubles in it. After that, I keep adding more elements until the array is full, or I give a negative number, and then I get number used. Okay, how many elements I have used, and I run this loop from 0 to count, and I print them out on my screen, and that will be it. So that will be my client code. If I look at the header file, this is no parameter constructor. This is a constructor that takes a single parameter. Also, this is a conversion constructor too. So this is a very dangerous thing actually. I should make this explicit. It should be explicit. Why it is explicit? Because let's say if I have a function that takes a PFRAD object, and if I send an integer to that function, if I don't make this explicit, it's going to work, right? Because this line says that I know how to convert an integer to a PFRAD, right? Unless I make it explicit. I made it explicit, now this problem is gone. This line says that I know how to convert a PFRAD object to a PFRAD object, right? Which is trivial, which is copy constructor. And this line says that I know how to convert an integer to a PFRAD object. Okay? Well, then you should do it only explicitly when I tell you. Don't do it by implicitly by making automatic conversions. So this is my one parameter constructor. This is my copy constructor as expected, constant and no reference. Why did I put this constant here? Anybody can tell me? Why did I put this constant in here? Yeah?
Show that I'm not going to change the object.
Yeah, that's one thing. The other thing is, I mean, I put it in there because I am nice, but this is more than being nice. This is prevent some compiler errors. If I like to make a copy of a constant PFRAD, I have to have this, right? If there is a constant PFRAD, I am going to make a copy of it. If I don't put a constant here, I can't make a copy of it. It has to be there. Okay, add element, just adds an element to the end of the array or PFRAD, which is like pushback. Full is, are you full? Am I going to, remember my initial size. Are you as full as that much? If capacity is the same as use, then I'm done. And the get capacity is return your capacity. Get number used is definitely less than or equal to capacity, right? Empty array just makes the use 0. And operator index, as we talked about last time, it just returns a reference to that one, and we like to do it this way. And we should have a constant. And okay, I'm going to return you a constant double reference, and I'm going to work on constant objects. I am not going to modify anything. An assignment operator returns a reference to itself. That's one thing. And it takes a constant right side reference. This is my destructor. Okay, let's look at the implementation. Any questions about this header file? Any questions?
In line 32, why we have double, why we have constant?
If my array is this PFRAD is a constant PFRAD, okay, then I have to type const here because otherwise it wouldn't work. Right?
So we don't want to change it.
What?
So we don't want to change it.
You can't change it. It's a constant PFRAD, right? If it's a constant PFRAD, you can't call line 31 on it. It has to be line 32. The question is same as this one. Why do I have a constant here, right? One is I'm saying that I am not going to modify anything. The other one is to be able to make this work on constant objects, then you have to do this. Remember what did you say about const? Const is all or nothing thing. If you are going to use const, use wherever it is usable. If you are not going to use it, don't use it at all. Okay? If you pick and choose, if you say, I am going to use const here, but not there, even though I can and I may, that's a mistake, because in that case, you are going to run into some compiler problems. If you choose not to use const at all, okay, first thing, okay, don't use it at all. Okay, don't use it at all. In that case, it might work. Well, you are not going to get a passing grade for this from this course if you don't use any consts. But if you choose not to use it in your professional life, then don't use it anywhere in your programs. Otherwise, again, as I said, you will have some const objects. To make your function run on that const objects, you need to make those function const. If the function is not const, then it's not going to work on that object, even though that function is not going to change anything. Okay, any other questions? Let's go to the implementation of the things. Constructor, it says, I am going to construct an object, okay, capacity is 50. I can hold 50 doubles. My use is 0, and I am reserving space for it. Okay, so I need to be careful about this new, because as an object I am responsible for that space. If I draw this, okay, if I do this PFRAD D110, then it is doing this. Capacity becomes 10. Use the 0. A is pointing to somewhere in my memory. Okay, this is in heap. Okay, this is in heap. And this one can hold 10 doubles. This one will be in the stack. This one will be in the heap. So when my object dies, object D1 die, this part will be taken away by the compiler's code automatically, but this part I need to be careful. I have to delete it in my destructor. The second one, very similar to this one, okay, very similar to this one, only the size is size and capacity is size. Use the 0. I didn't check any. I didn't do any. The checks, limit checks, size cannot be less than or equal to 0 thing, right? I didn't check it, so it's a simple a mistake in there. Let's look at the copy constructor. Let's try to visualize what the copy constructor does. Okay, copy constructor says that I get an PF array object, other object. Okay, I got it. I am going to copy the capacity of it. I am going to copy the use number of it, okay, to myself. Then I am going to allocate some space. I am going to allocate some space, like capacity, and I am going to copy the other objects values, doubles, one by one from 0 to used. Okay. If you don't implement this copy constructor, remember, this is what happens. Remember what is our default behavior for the copy constructor? It is shallow copy. If you make a copy construct, if you call this D1 copy of D2, and if you did not implement your copy constructor, your default meaning of member-wise copy will be taken. So it will be this capacity will be copied to capacity, use will be copied to used, A will be copied to A. So I am going to copy this pointer. So I am going to end up showing the same heap location on my memory. Okay, on my memory. So both of them are sharing the same double array. So if I modify D1's the second element in this array, DT will get affected. Okay, you might say that, well, man, that's not a computer, that's not a crash, right? Your program is producing wrong output because I am modifying D1's elements. D2 is getting affected too. That's a bad thing, but it's not. You might say that it's not a crash. The thing is that it's going to cause a crash. Why? Okay, tell me how is this going to cause a crash? The default meaning of the copy constructor does the shallow copy, and I already told you how this is bad, because if I modify this D1 to 7.2, it will write 7.2 here. So D2's second element will change too. Okay, that's a logical error. That's a bad thing, but at least it's not a crash, you might say. But I'm saying that no, this will cause a crash too. Hint is going to cause a dangling reference. You might say, well, how come it is going to be a dangling reference? Both of them are referencing to some place that belongs to me, right? But it's a dangling reference. It's going to cause a dangling reference.
Even if we assign their pointers to null pointer with destructors.
Say it again.
Even if we assign their pointers to null pointer with destructor.
What do you mean? You mean if you do that, it's not going to cause a crash? Well, even if you do that, it's going to definitely cause a crash. So say, tell me what you are saying about the destructor.
After deleting delete pointer, then assign pointer to null pointer.
I guess what you are saying is that if D1 or D2 goes out of scope, if one of them is dead, okay, what's going to happen? I am going to call the destructor, right? So the destructor is going to say that, okay, delete this pointer A. A is pointing to this location. When I destroy the D1, when I destruct, okay, D1, it's going to destruct all of the space. Also, it's going to give away the space too. But D2 is still pointing to some location, that location, right? D2 is still alive. So what's going to happen? D2 is causing a dangling reference, okay? D2 is going to cause a dangling reference, and that's going to be a That's going to be a bad thing. Okay?
But when we use in the same scope, it won't be cracked.
Well, that's a very good question, actually. I mean, what happens if I do this? They are in the same scope, right? They are in the same scope. They are in the same scope. I did this. This is a bad thing. I modified D2's second position too. That's a bad thing, but it's not a crash. Still, you may crash here. How? I mean, they are both at the same time going out of scope, right? They are being distracted at the same time. Still, this is a crash. How? Which one is going to die first? D2, right? D2 will die first, and it's going to take away this array with it. Then D1 is going to die. What does D1 do when it dies? It will say that I am pointing to this location belongs to me, I am going to delete it, right? You are deleting some place that doesn't belong to you, and that's going to cause a crash. One, two, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 people are like holding their phones and doing something. It's so obvious when you play your phone. You aren't listening to me. Okay? You understand what's happening? So even if you do this, this may cause a crash. To test this, you write this program and test it, okay? Just remove the copy constructor, try to get those crashes, and try to run it again. Don't play with your phone. Put it away.
Can you give a quick explanation again?
Why? This is a crash. When this one dies, D2 died first, right? When it dies, it says that delete this array, right? It deleted it, right?
This is one part.
Yeah. When D2 dies, it will take this array with it too, when it dies, right? When D1 dies, D1 thinks that this array belongs to it. It will try to kill that one too. So it's going to crash. It may cause a crash too. At least it's going to make the memory allocation procedures of C++ compiler confused. Well, not good things will happen. It's going to be bad. Yeah.
What if it points to an integer, not an array, and we don't delete when we call destructor? Does it crash?
Say it again. I don't understand. No.
What if it points to an integer, not an array?
Well, a pointer points to an array, right? Oh, you mean it is not an array, but it's a dynamically allocated double, just a single double, right? It's the same thing, okay? This one will kill that double, and this one will think that I still have that double. It doesn't have to be an integer or single pointer or an array. As long as it's a pointer, okay, is pointing to the same location, is going to cause a dangling reference, and after the dangling reference, things are going to be bad. With the deep copy, this is our picture, right? Copy constructor, remember what it did? Say that D1 is this, D2 will copy capacity and use exactly, but it will make its own copy of the array like that, okay? I got a new place, and I copied the elements one by one. That's what we did here. I have a new place and copy the elements one by one. Add element. Add element says that if use is greater than or equal to capacity, then I can't add anything. I am exiting. Otherwise, my use position will be element and my use will be plus plus. Okay, so I don't know why book chose it this way, but it is very easy to make it not restricted by the capacity. I can increase the capacity by 2 times, and I copy my old elements to the new place, and I can continue doing this, and I'm going to modify it in a few minutes after I am done. Okay, this one is very simple. If index is greater than or equal to use or less than 0, maybe illegal index, less than 0 should have been. Otherwise, return this one. Remember what I said about this constant thing? Control C, 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 and it's going to be just const here and const there. Implementation will be exactly the same, no difference. Okay, these two will exactly have the same implementation. Okay, assignment operator. Let's write the assignment operator together. I am going to write this here. Okay, so at the end it says that return something. I'm going to return star this. Okay, after I did the assignment, I am going to return a reference to myself, so I can do the cascaded assignment. What am I going to do? With the right side, I am going to copy its used with others used, right? Its capacity with the others capacity. Then I need to copy its content. Okay, so I need to make new array, and I need to copy to that position. But I have to be careful. Why? Because I am already a living object, right? I am pointing to something. The picture is something like this. The picture is something like, when I say A gets the value of B, okay, why don't I make this a little bit smaller, like this? This is my A, okay, inside my A I have capacity and use. This is my B, inside, okay, so this one is pointing to this big location. This one is going to, okay, point to, so this is my double array. This is A and B. Okay, I am trying to do what? I am trying to assign the values of B to A. B will not be modified, but A will be modified. So this is like copy construction, right? But it is not copy construction thing. Why? Because both A and B are alive. They are already objects. When I do this deep copying from B to A, okay, A may not have enough space, so I need to reallocate some space, but I need to get rid of this space too, okay? I need to get rid of this space today, so there needs to be some kind of a deallocation. So I need to be careful about that. Also, I need to be careful about this kind of a stuff. If somebody is crazy, it is doing this, okay? I need to check that if the other side is same as me. If it is same as me, then I am not going to do anything. Otherwise, if I start doing deallocating my space and copying from the other space, I mean, if I deallocate my space for B, well, the other one is myself too. I deallocated others A too, so that's a crazy thing. So I need to be careful about that. So usually this would be our first thing. So I am going to make this other, just to keep it, okay? If others address of other is same as my address, this means what? The other object is same as mine. Our address is the same thing. I just return this. That's it. Okay? Otherwise, I made sure that the other object is not mine. Okay? Otherwise, I just immediately delete my A, remember A is my pointer to the double, right? So what am I gonna do now? I deleted my, I release my, I deleted A, I release my, now I am doing this. Okay, so A is not pointing to anywhere now. Okay, I deleted it. So if I do this, that will be a bad thing. It will be a shallow copying. That would be a bad thing. I am not going to do that. Okay, so maybe I should what? Tell me. Right after this one, what am I going to do?
Allocate a new memory. Allocate a new memory.
Allocate new memory. So I am going to say A, okay, maybe I should do this. Before allocation of memory, my capacity will be the same as others capacity, other dot capacity, and my used will be the same as other dot used. Okay, and A will be new double and capacity, right? Okay, so my capacity and use are already done. What am I gonna do? I guess I will run this loop from 0 to I less than what? I less than what? Use or capacity?
Use.
Yes.
Why not capacity?
No need.
We didn't use.
Can I write it capacity? Is it a logical error or compiler error or something? Capacity. What happens if I do this capacity? I use only use number of elements in it, but the whole capacity belongs to me. So this is not going to cause a crash, but it will be a little bit inefficient, right? So I think it's better to use used, and of course plus I, and I am going to say, okay, my AI will be the copy of other dot AI. If I can find my, yeah, okay. I guess that will be it, right? I deleted my A, okay, my pointer, and then I copied capacity and used. I allocated some new space and I copied everything in using deep copy technique.
We should
So,
return
what?
A. Not this.
What?
In line 63, we should return A.
I should return what?
Not. We should return not these. We should return our new composed A.
What should I write here? OT?
Not OT.
It could be OT too. Well, I cannot return OT because this is constant. I am returning myself. So what is wrong with returning yourself?
A is a
We
pointer
are
of
not
this.
updating
What?
ourselves.
A is a pointer of this actually. A is not an option.
Oh, what are you talking about? Is it 63? You are talking about 63? So what should I write? You are talking about something different.
No, he said we should
Just
return A, but A is not an object.
Oh, you are saying that I should return A? No, of course. A is a double pointer. What is this? This is a pointer to object. The reference this is a reference to this object. I am returning this.
But we don't update it, the reference these with AI. A. Error. Did we?
I don't understand what you are saying. Well, A is something inside this object. I have three things: capacity, used, and A. I updated all of them, and I am returning this one. Okay, good. So let's see how the book implemented this. I think it was a little bit different. I think it is a little bit smart, but don't follow my template, okay? And for this case, maybe book implementation is a little bit more efficient, but usually we started with this case, like, is this the same as mine? If it is, then do that, okay? Say that if my capacity is not the same as right side capacity, so you say that if the capacities are same of both objects, right side and mine, then I don't have to allocate anything because I already have enough capacity, right? Okay, so if capacity is not the same, then delete A and get a new array, right side capacity. If it is not the same. If it is the same, okay, then I just continue, then do this. Capacity is right side capacity, use the right side used, and copy stuff. So if the capacity is good enough, then I am not reallocating the space and deleting and etc. I am doing this only if the capacity is not good enough. And in fact, this would have been better if my capacity is less than or equal to right side capacity, or greater than equal to, or less than or equal, greater than equal to, greater than equal to, or less than, sorry. If my capacity is less than the right side capacity, then I don't have enough space to store all of that, right? So I am deleting mine and I am getting new capacity size stuff. This one says that if it is not equal to, then do it, but I'm saying that it is okay to have larger capacity, okay? I did this, and I did the deep copying, and that will be it. How come it didn't check? How come it didn't check if this other side is same as mine? Are they doing something bad? The answer is no. Why not? I didn't check if the other side is... So what's going to happen if somebody says A gets the value of A assignment A? Isn't that going to be a problem? Am I not going to delete my array A in that case? No, why? Why no? Because if somebody is doing A assignment A, then my capacity will not be less than the right side capacity because my capacity is same as others' capacity. So I will not delete anything. I will continue. Okay, good. So my destructor is as simple as this. Whenever you die, okay, better thing would have been maybe do this too. Well, why do I do this? When I make this a null PTR, I don't just make this a rule of thumb. Always deletion do this null PTR. Even though A is going to go away. Remember, A is part of the object, is going to go away. Make this a habit of yours, and it's going to be beneficial in some cases. Good. So this is PFRAD. There is something that I don't like about this class. It is this one. I don't want this add element. Where is my add element? Add element to give me this error. So I am going to get rid of this one. Okay. Get rid of this one. I am going to increase my capacity. If use is greater than or equal to capacity, I will do this. I will increase my capacity by 2 times. My capacity will be 2 times. Of course, use will be the same, but I have to deallocate my old memory and allocate some new stuff, then copy the old one to the new one. So let's start with this. Delete my old space, delete A. I deleted my array that I am holding. Then do what?
Increase the capacity by 2.
Then increase the capacity, then do
Copy.
copying. Is that a good plan? Deleted my array.
Yo, that's lost.
Yeah. So this deletion should be delayed a little bit. You should not delete anything before you copy the stuff out of it, right? So let's increase the capacity. Capacity is okay 2. Now capacity is my 2 times the capacity, right? And so let's try to show it on the screen like that, okay? This is what I'm going to do. Okay. This is my object. This is, let's say, my A used and capacity. Use is 10, capacity is 10, okay? And A is pointing to this location. What I like to do is, make this capacity 20 and make this point to somewhere in the memory like this, and now I have 20 doubles in it. Previous I had 10 doubles only. Okay, keep this in mind and let's go back to our thing. Capacity is 2 times. Okay, I did that already. Am I going to change used? Used is exactly the same thing, doesn't matter. So let's get some double array, double PTR, okay, double array, and it's going to be new double, how much? Capacity is already 2 times, right? Capacity. Okay, so I have now I have a pointer DA, it is pointing to this capacity. My A is still pointing to my old place now. Okay, then let's do this integer I from 0 to I less than how much? Used or capacity? Yes. How about capacity? Capacity is 2 times the thing, so it has to be capacity over 2. Used is much better, right? Then plus I, and then what? Then DA, DAI will get the value of AI, right? Okay, so I copied it. So what am I going to do now? Well, delete A after that. Now A is a dangling pointer, right? So what am I going to do? A is going to be DA. It's going to be like this. So I created, okay, this is the picture. The picture is not, okay. I created a temporary object or pointer DA, and DA is pointing to this location. And while I am doing this, I copied my elements one by one to this place. One by one I copied them to the first 10 positions. DA is pointing to this, A is pointing to this. If I make this assignment, A gets the value of DA. Now both of them will be pointing to the same location, right? So this one will point to that location. Okay? So that will be it. So if use is greater than or equal to capacity, increase the capacity, allocate some new space, deep copy, delete my old A, update A, and the A will go away. It's just a simple pointer. And after that, A used now can be used to make this assignment, and then I increment use by 1. So this is simple enough. My complete thing is done. It's a very flexible code. I don't have to think about my capacity at all. It just works. Okay. Good. This is how vectors are implemented. Okay. This is how strings are implemented. There is nothing much. So you need to know a few things. But this copy constructor, okay, destructor, assignment, those big three, those are important if you are involved with this kind of memory stuff. Because member-wise copy will fail you in those cases. Okay? You need to do deep copying. You need to do deep copying. Okay? Any questions so far? I guess that will be end of this chapter. Did I miss anything? Yeah, I think we are fine. Question for you. This is a very classical question. Everybody asks this one. How come I don't have any delete operators in my copy constructor? Remember when I do the assignment? When I do the assignment, where is my assignment? Okay, I am deleting the array that I am pointing to A. When I do the pushback or add element, I am deleting my old position A. How about this one? In copy constructor, I have two objects. How come I am not deleting my old position A? Who is talking? Yeah.
One of them is not initialized.
Say it louder.
One of them is not initialized.
I mean, I am already constructing a new object. I did not allocate any space at all, right? I am constructing a new object. So A, used, or capacity are not meaningful things for me because it's a new object. Okay? So that's why I don't have to delete anything, or I should not delete anything, because if I try to delete A, then there's a dangling reference problem. That's going to be a bad thing. Okay? That's why I don't delete anything in my constructor, copy constructor. Yes?
Why does the program just deallocate memory space which is owned by more than one pointers? So let's say PTR1 and PTR2 are pointing at the same space.
Yeah.
And we are deallocating one of them, and the other one is also deallocated, right?
Well, if you do shallow copying, you have to be careful about that, but we are not doing shallow copying, right? We are doing deep copying. Yeah. When you deep copy, no two A's, this A, no two pointers will point to the same location.
Well, the compiler is smart, we said, and if it's smart, then it shouldn't just deallocate the space.
It's not a task of, well, this is happening during the runtime, right? Compiler is gone. Compiler produced a code for you, okay? And the code, what's going to do, compiler wouldn't know about it, right? Compiler would not know if two things are pointing to the same location, and compiler would not know if that's the thing that you want, okay? Sometimes we like to point to the same location with many different pointers, if we like to share them, okay? Pointing to the same location with different pointers is not a bad thing. But if you try to deallocate all of them at the same time, it would be a bad thing, okay?
One more question.
Yeah.
Why doesn't it allow us to free it more than one times? Like, if we freed it...
Because it confuses the memory allocation system. You are saying that, remember I had this location before, yeah, I am deallocating it. They believe you, okay, even if you don't have it. If they try to run checks on them, okay, if they try to adopt you and they say, okay, I don't believe I'm going to check it, it's going to be a loss of time to check if that place belongs to you or not.
But it knows whether I freed it 2 times or not.
It doesn't know, no.
Double free detected error. Yes.
No, it doesn't know. It doesn't have to know. Sometimes it knows it. If it spends a few more CPU clock cycles, it would know, but it doesn't know. Well, it is not that difficult to check if you are accessing out of bound index in your array, right? If it is less than 0 or greater than index, but vector doesn't do it, class vector. even though it can. Why? It is inefficient. Okay? It trusts you. Okay, good. Any other questions? Okay, that will be it for this chapter. Next time we are going to start talking about, I don't know, next chapter.